Hey, good morning and welcome. How's everyone today? Hey, Amrith, how's it going?
Hey Sanjeev, awesome. How you doing?
I'm doing all right. So for everyone joining the live stream, just hang out for a bit. We're gonna give maybe a couple more minutes for everyone else to join, and then we can go ahead and get started on this week's session. So we'll just hang out for a bit. What time is it over there?
1 a.m.
1 a.m. Okay, all right. So I'll make sure to drag this out as long as possible.
You can do it. I'm just, the day has just started, let's say that.
Yeah,
And what time is it over there?
it's 7 a.m.
Ah, beautiful. And how's the
Yeah.
weather over there?
It's finally gotten a little cold. It's finally started to get some snow on the mountains too.
Ah, okay.
So
You know,
ski
we are in,
season's about to kick off.
that is, it's Christmas anyways, right?
Yeah.
So I think getting there. Here it's the opposite. It's summer. So
Oh,
tomorrow it's
that's
going to
right.
be 30
Oh, so all of
degrees
your
Celsius.
Christmases are always warm, I guess.
Yes, so we can actually go to the beach while
Uh,
you
right.
spend time in snow, which is much more fun actually.
Yeah. All right. So let's go ahead and get started. So good morning, everyone. I just wanted to welcome you guys to the fourth Golden Kubestronaut Cohort session, the fourth of 5 sessions that we have scheduled. My name is Sanjeev Thiagarajan, and I'm joined by.
Hi, I'm Amrith Raj. I'm an observability advocate, and I'm also the OpenTelemetry co-instructor for the OTCA course at KodeKloud.
Yep. And so just to recap, if you guys haven't attended any of these previous sessions that we've had, the main goal for these sessions is to one, offer guidance, provide tips and tricks for passing certifications and getting your Golden Kubestronaut, as well as answer any questions you might have about the Golden Kubestronaut and any of the certifications in that track. And so each session will focus on a couple of different certs. For this session, the name of the game is telemetry. So we're going to be covering all of the telemetry associated certifications of the Golden Kubestronaut. So that's going to include the Prometheus Certified Associate Exam and the OpenTelemetry Certified Associate Exam. And so, as Amrith mentioned, he is the creator of the OpenTelemetry course on KodeKloud. I myself created the Prometheus course on the platform as well. So if you guys have any questions about those courses or about the exams themselves, please let us know. That's the purpose of these sessions. We want to help answer any questions you guys might have. We have a Q&A session at the end where you guys can ask your questions. But what I recommend you guys do for this session is, if you have any questions, ask them right away. So we'll save all of the chat, ask the questions in the chat, we'll save them. And so that way, once we get to the Q&A, we can just start, answering those questions right away instead of having to kind of wait for all of those questions to roll in. All right, so as I mentioned, we're going to be focusing on the Prometheus Certified Associate and the OpenTelemetry Certified Associate exam today. So our agenda today, we're going to be talking about, why Prometheus and why OpenTelemetry matter. We're going to understand the critical role that observability plays in cloud-native infrastructure, as well as in the Golden Kubestronaut certification path. We'll then dive into the Prometheus Certified Associate exam and take a look at all of the things that are going to be covered in that. And that's going to include things like the different metrics that we have available in Prometheus, how to utilize PromQL for querying, as well as alerting and other certification requirements or things that you got to know for the certification. Following that, we'll move on to the OpenTelemetry Certified Associate exam. We'll dive into that. We'll take a look at how to instrument your application with OpenTelemetry. We'll dive into the different telemetry signals that make up observability, as well as see how to implement a OpenTelemetry collector as well as the different architectures that you have when it comes to deploying collectors. On top of that, we'll then also take a look at the different resources that we have in KodeKloud that can help you pass these 2 certifications, as well as all of the other certifications in the Kubestronaut path. We'll take a look at the different tools that we have available within those resources, like hands-on labs, mock exams that are there to kind of simulate what you might see in the actual exams themselves. And then we'll wrap things up with a quick summary and then Q&A. You guys can ask any of the questions that you guys might have. All right, so let's start off with Prometheus. So if you guys don't know, Prometheus is an open source system that collects and stores metrics so that you can monitor your application and infrastructure and make sure that they are performing as they should. And so it's going to regularly pull data from your services and store it as a time series, which you can then query and trigger alerts based off of certain thresholds being met or crossed. It's going to basically let you know if your system is healthy or something's wrong with it. And so with Prometheus, there's a lot of different components. It's not just Prometheus. There's a whole kind of ecosystem within Prometheus of all of the different pieces. And you're going to need to know how all of them work together and the role that they play inside the Prometheus architecture. So you're going to need to know things like, what are the different metrics that you have available? So things like, what's the difference between a counter metric versus a gauge metric? You're going to need to be very proficient at PromQL, which is the query language for querying data from your Prometheus server. You're going to need to know how to work with Alert Manager. So that's going to be the portion of Prometheus that allows you to generate alerts, send notifications to whatever tools or systems that you use to notify your team. And then on top of that, there's going to be things that you need to know when it comes to administering and running a Prometheus server. So whether that's running Prometheus in a high availability setup or just scaling up and down Prometheus, how do we actually scale it up if we're starting to reach limits on its performance? So for the PCA exam, it's going to be exclusively a multiple choice exam. So there's no, like hands-on or anything like that. It's just standard multiple choice based questions. You get 90 minutes, and if you pass the exam, you get your certification, which is valid for 2 years. Now, for the exam, the core domains, they're going to include observability concepts, which is 18% of the exam. So this is just kind of the basics of observability. What's the difference between metrics, logs, traces? You need to understand the difference between a model, what's service discovery, as well as understand what are SLOs, SLAs, and SLIs. Then you have Prometheus fundamentals, which is 20% of the exam. This is going to be covering the basics of Prometheus. So what is the system architecture? What are the different components? You're going to have to know how to configure Prometheus so that it can scrape endpoints for metrics, as well as understand the different metrics that you have available and the different counters and gauges and histogram metrics that you can use to actually create metrics. After that, we have the PromQL, which is 20% of the exam. 28% of the exam. So this is going to be all about querying Prometheus using its native language, which is PromQL, being able to select data, matching on labels, calculating rates, aggregating data over time or various dimensions. Then we have instrumentation and exporters, which is 16%. So this is going to be all about, how do you set up an exporter? How do you implement instrumentation in your application using client libraries, whether that's Python or JavaScript, as well as best practices when it comes to creating and naming your own custom metrics. And then finally, we have alerting and dashboarding. So this is going to be all about how do I configure a dashboard to visualize the metrics in Prometheus? How do I configure various alerting rules? How do I work with Alert Manager so that I can alert my team when something is wrong with our system? So some of the fundamental things that you have to know for the PCA exam is really understand the push versus pull architecture. So Prometheus follows a pull-based scraping model. So it's going to send an HTTP request to a endpoint, usually the /metrics endpoint to your various applications, and it's going to pull the metrics when it wants to. So on a predefined interval, it could be every 15 seconds, could be every minute, depending on how you configure it. So you need to understand it follows a pull-based model, and you got to understand what are the benefits of that? Why did they choose to do that? There's a lot of benefits to using a pull-based model. One of the things could be, when you follow a pull-based model, when your targets are down, right? The scrape will fail. On top of that, you can avoid any situations where you have a whole bunch of applications that, overload your Prometheus server, right? And they just start pushing and flooding metrics. So following a pull-based model kind of helps alleviate some of those different problems. So make sure you understand all of the benefits and trade-offs that you have with a pull versus push-based architecture. You're going to need to understand how all of the different components that make up Prometheus and the whole solution. So whether that's the Prometheus server itself, which contains the time series database with all of your metrics being stored. You need to understand what are exporters, which, if you're running like an application or a MySQL database or anything, you can configure an exporter to collect the metrics and expose an HTTP endpoint for Prometheus to scrape. You need to understand things like push gateway. So when you follow a pull-based model, it's going to be hard to collect metrics for short-lived jobs. So you have to implement a push gateway for those short-lived jobs or those batch jobs, as well as understanding Alert Manager, how to configure it, and how to set it up to actually generate alerts. And then, as I mentioned before, you need to be really good with understanding the different metrics that we have available. So you got counters, right? Counters are exactly what the name says. They count up. So they're great for tracking things like what's the total number of exceptions in my application that I have experienced, or what's the total number of requests my application has processed. So counters are always going to count up. We have gauge metrics, which can go up or down. So if you're tracking, let's say the temperature in a data center, right? At some point it can get hot, sometimes it can get cold. So it can go up or down. It's great for tracking things like memory utilization, CPU utilization. Then you have histogram, which is it's all about setting up these buckets where your data is going to be placed into those buckets. So if you're tracking, what is the latency or how long does your system take to process a request, you can create these buckets. So you could say like, okay, a request took under 50 milliseconds, under 100 milliseconds, under 500 milliseconds, under 1 second. And every request you get is going to put it into one of those buckets so you can see how your system is overall performing. And then you have the summary metric, which is very similar to a histogram metric, but it works with percentages and quantiles directly. All right. Now for the exam, you have to be proficient with PromQL. So you got to be able to know how to select metrics, as well as use labels to select on specific time series. So if you have a metric called HTTP request total, you can select that by just doing HTTP underscore request underscore total. And then if you wanted to see all of the requests that had a HTTP method of get, you could do method equals get. That's matching on a specific label. So you got to know how to use labels to filter down on the specific time series that you're interested in. You also have to understand the difference between the result of an instant vector versus a range vector. So if you do HTTP request underscore total, and then you do brackets 5 minutes, that's going to show you the values for all of the intervals within the past 5 minutes. You also have to know how to use the aggregation operators, so performing a sum or an average or a max or min, as well as being able to group by various labels, like we see here where we're grouping by the job label. You also need to know the common functions that are used in Prometheus, so like calculating rate or irate, understanding the differences between those and how they're calculated. Other functions like increase, or some of the common math functions like absolute, ceiling, natural logarithm, or floor. So those are just basic mathematic operations. And so the PCA exam, it's going to test your ability to interpret the query intent and select the correct PromQL expression for specific monitoring scenarios. So you're going to need to understand query semantics, not just the syntax. Other things you're going to need to know, you'll need to be proficient at configuring a Prometheus.yaml file. So understanding what are the global configurations that are which are configs that apply to all of your scrape jobs. You'll then also have to configure individual jobs or scrape configs, and understand how to use relabel configs for filtering metrics as well as enriching targets. You need to understand the difference between statically configuring a job versus dynamic discovery using service discovery. So you can use, if you're running Kubernetes, you can have Prometheus automatically pick up when new pods get created so that you don't have to manually update it in your Prometheus configuration file. And you can do this with a variety of different platforms. So you could do this with EC2 as well. And then you also need to understand when and why you would use a push gateway versus just usual exporters. So push gateways, we talked about how Prometheus follows a pull-based model where it'll scrape your endpoints every minute every 15 seconds, depending on what you configure it. If you have a short-lived job that takes like 2 seconds or a couple seconds, you might not be able to scrape it in time. So you would have those short-lived jobs push it to a push gateway, and then Prometheus scrapes those metrics from the push gateway. So they're there for short-lived jobs. Now, some tips for preparing for the exam. Make sure you understand the different metric types, right? Really understand when you would use a counter versus a gauge versus a histogram versus a summary, because you will be asked on the exam about that. You should be very proficient with PromQL, so being able to calculate rates, aggregations, very common troubleshooting queries. You should be able to read the Prometheus.yaml file and understand when there's a mistake in the configurations that would cause Prometheus to not function or work properly. And the same thing goes for alerting rules and recording rules. And you need to be very proficient at using Alert Manager. So understand the different features of Alert Manager, understand how to group alerts, how routing works, inhibition, silences, how to connect it with various receivers, as well as how to customize messaging templates. And then, as usual, make sure you get as much hands-on experience as possible. The more hands-on experience, the more naturally you're going to pick up and remember all of the different aspects of Prometheus, whether it's working with PromQL, whether it's working with instrumentation or working with Alert Manager. It's just going to help reinforce those ideas and keep it inside of your head. All right, so now we're going to move on to OpenTelemetry. So I'm going to hand it off to Amrith, and he's going to take over from here.
Thanks, Sanjeev. I think I really liked that Prometheus is all about metrics and alerts. Yeah. Now we're going to take to the next level with OpenTelemetry. So why OpenTelemetry and OTCA, right? OpenTelemetry represents the open standard for unified telemetry across not just metrics, even traces, logs, profiles, and there are baggage, right? So these are called signals in OpenTelemetry. And unlike you need vendor-specific agents, OTel provides a single vendor-neutral instrumentation layer that works across any observability backend. So for metrics, it could be Prometheus, but it could go to any different backend as well. So that's the beauty of OpenTelemetry. It's an absolute open standard for any signal, any telemetry signal. So the OTCA, the exam, it validates your skills on observability fundamentals, very similar to what you've seen with Prometheus. You would want to know what the signals are, like metrics, logs, and traces. Then you would focus on OpenTelemetry itself. What are the key core concepts? Then you learn about span anatomy. What is a span? What are the different attributes within a span? And what is context propagation? When a request goes from one distributed service to another distributed service, how does the context propagate from that specific service, and how is it copied? How is it done? What headers are they using? Then we'll look at the instrumentation patterns. How are you going to instrument this? So we want these signals. We want metrics, logs, and traces. How would you instrument it? So there are manual, library, and auto instrumentation approaches. Then similar to what Sanjeev covered about the metrics, which included histograms, counters, gauge. So OpenTelemetry also makes sure that the Prometheus data model of metrics are there. So you have the metrics data model that would cover them. Then how would you create these metrics? You could use collectors to create those metrics, or you could instrument within your code as well. And that's where you would record measurements. And then we speak about logs with OpenTelemetry. Okay. With all these signals, what you do next, you would send it through the OpenTelemetry pipeline. So that's through the collector, right? And we'll talk about the OTTL, the deployment strategies with Kubernetes, schemas, and debugging, right? So OTCA is part of the golden Kubestronaut, and it represents the unified and open observability layer. Today, LLMs, LLM models, the way in which you want to understand anything from those machines, it's through OpenTelemetry, right? And that's how you can understand the performance of LLMs as well. Next slide, Sanjeev. So from an exam perspective, similar to what you've seen with Prometheus, 18% is the fundamentals of observability, where you cover observability versus monitoring. What exactly is observability? How is it different? And what is unknown unknowns? and those fundamentals. The next is the major core component of OpenTelemetry. It's the OpenTelemetry API, SDKs, which also includes the data model as well. So you'd have that information about how you create these telemetry signals for metrics, logs, traces, baggage, profiles. So you'll learn how to create them by hand, through code, or even automatically. How can you do that? So that's covered in the course, and you'll be tested in the exam. Next 26% is about the collector, the OpenTelemetry collector, how all these signals are sent into the collector and how it's sent out, fanned out to the various observability backends. And then 10% is all about maintaining and debugging observability pipeline. When things go wrong, how would you troubleshoot it? Where would you find issues? So that's covered in the debugging section. Next slide, Sanjeev. So why OpenTelemetry? OpenTelemetry is the vendor-neutral telemetry standard. It started a couple of years ago, but the key aspect is this is going to stay for the next future, because there was no standard available on sending telemetry data from machines. There were many vendors, but they were never neutral. And this is where OpenTelemetry emerged as the vendor neutral telemetry standard, where you can instrument once and reuse across platforms. And there you have the consistent signals and semantics everywhere. If you remember what Sanjeev had mentioned about HTTP request total, so that request total would be defined in OpenTelemetry as a semantic convention. Like any platform you're going to use, you would say that HTTP request total will be the standard. There's no way you would want to call it something else, right? So that's covered in the semantic convention. Next. So you'd cover the key concepts. We'd talk about the signals, that's metrics, traces, and logs. We would want to identify where are these metrics coming from, and that's in the resource section. What is a resource? It identifies the source of where the telemetry is originating. Then when that telemetry is coming through, how would you add some key value pairs? You want to add some, say, user ID, or you want to add some location, you want to add the host URL. So that's the attributes that you can attach to those telemetry signals. How do you do that? So that's something that we cover. And from an exam perspective, we'll talk about the observability. We'll get to the data model. How would you instrument? What are the various different APIs, SDKs that you'd use to instrument? The context propagation. Are you going to use the W3C headers? What are B3 headers, if you have heard of that? And then the collector pipelines, debugging. So that's the key focus from an exam perspective. If you can go to the next slide, Sanjeev. Thank you. So similar to what Sanjeev mentioned, what are metrics? Metrics are numeric measurements over time. It's pretty powerful, as Sanjeev alluded to, with counters, histograms, gauges. You would find them. Now, unlike traces and logs, metrics are much more versatile. You would see concepts like temporality, whether how the metrics changes, how is it different when the time elapses, whether it's cumulative or delta. You could understand the health of the system. And when you understand the health, what are the key aspects that you would want to understand? Is it the load time? Do you want to see it in a histogram, or whether you want to see in a simple counter or a gauge? Then when you have so many metrics, do you have limited number of dimensions? Is it coming in from one process or two processes? Metrics are typically on the lower side of cardinality. We would understand, and you would take a deep dive into that as well. Next. So traces is the most fun aspect, because here you're seeing how a request goes from one service to another service. There you learn about the span timings. How much time did it take running on a Go process or a Node.js process running on an EC2? And where was the exception thrown? And with that exception, did it affect the user? And if so, what was the error thrown by that exception? That's all seen only by traces. It's great for bottleneck and latency debugging, and we'll see this in quite detail. Then comes the oldest signal. The oldest signals is logs. Logs are simple. If you want to remember the print statements, the standard input or standard output that you write down. So logs are the oldest signals where you could see the timestamped messages, but it is detailed. It provides you a lot of rich context with attributes. And then trace correlation. You can click on a log and then you could switch to the trace as well, because they're all correlated as well. Same with metrics. You will learn in the course how you can use exemplars where the metrics can correlate to a trace. So logs again are the best signal for detailed diagnostics and error analysis. So you might see a question like, what is the best way, which instrument types fits the best here? And if you want to identify what is the request that's going from one signal, one service to another signal, are you going to use a metric? Are you going to use a trace or logs? So we'll cover all those things in the course. Next slide, Sanjeev. Right. So with those signals, how would you create them? So we will cover the core and the most hardest way of instrumenting, which is going to be the manual. This would help you understand how developers actually instrument the applications and how we should encourage people and developers to instrument. And that helps OpenTelemetry and observability become invisible. When we say invisible, that means it should simply work. And that's the whole goal of OpenTelemetry. Now, that's the manual way. You learn the hard way of doing it first. Then, next, you learn about the library-based instrumentation, where for common libraries like Flask or Spring Boot, you don't have to instrument them or HTTP request. There are already OpenTelemetry library-based instrumentation that's available. So you could simply add those libraries and then voila, you get all the instrumentation and you get traces and metrics in a couple of easy, simple ways. And then finally, you have the auto instrumentation. What if you don't have access to the code base? What if you don't have that? You don't have the developer who actually wrote the code. And this is where ops teams, SRE teams, sysadmins can instrument applications without even touching the code. So that's where the auto instrumentation of OpenTelemetry plays a critical role. And that's how you typically start taking advantage of OpenTelemetry. And we'll cover all the various things within auto instrumentation, like monkey patching, the bytecode injection, and all those aspects, and how it all fits together. This is why we learn the hardest way first through manual, and then we progress through library-based and instrumentation. With all the signals that we get, how are you going to send these data out? So that's where the OpenTelemetry collector plays a role. The OpenTelemetry collector serves as a vendor-agnostic telemetry pipeline. It helps in receiving, processing, and exporting the telemetry signal. It can receive in any format, like Prometheus, for example, or OTLP, the OpenTelemetry protocol that can work for metrics, traces, and logs as well. Or from other technologies, like imagine you're running on a machine and you want to get those host metrics, you can use that, or Kubernetes metrics. You could use a collector for that. Next. So the pipeline components includes receivers, like ingesting telemetry from OTLP, Prometheus, Jaeger, Zipkin. Then we have the processors that can help in transform the data, like batching, adding additional attributes if you forget to add that, or if it's too hard to do that at the instrumentation, or you want to filter the data. Hey, there are some PII data somewhere. You want to mask those. So that's where you could use the filtering aspect as well within the processor. And then when you send it, where you're going to send it, you can send it to a backend, like an observability backend or a vendor-based backend, or you could send it to Prometheus as well to see those metrics, or Jaeger, or your vendor-specific backend, or another collector itself where you want to do some processing, further processing. Next, Sanjeev. For Kubernetes, there is interesting concepts like the agent mode, where you deploy the collector on each node, or sometimes even the pod, or on your local machine where you can consolidate that, or on the gateway where you have the centralized collector. You would learn these patterns in the course. And then there is the hybrid way as well, where you have the agents forwarding to the gateway, and then the gateway forwards to another load balanced and stateful sets, and that would forward it finally to your backend. So you would learn everything with respect to the OpenTelemetry collector and much advanced concepts within the course. Next slide, Sanjeev. So with the concepts that we have seen, what does the course help you prepare? So we go through a structured learning path for the OpenTelemetry certificate. So we'll cover OTCA concepts well to the basics to the advanced level as well. We go through simple fundamentals. We're not going to make it difficult for the learner. It's going to be in a most simplest format. And then you'd get access to hands-on instrumentation. Gone are the days where simply you read through it. Here you have live experience on how you could instrument it, how you could instrument apps using OpenTelemetry's manual instrumentation, your auto instrumentation. You learn how to use the SDKs and APIs. Then you learn about the OpenTelemetry collector configuration, the pipeline architecture. Then you see about how you integrate that with Prometheus or other backends. Then you'll have some real world demos and practical scenarios. Now, from an exam perspective, the exam style, it's a multiple choice question. It would typically have about 60 questions. And then you'd practice scenarios within the course as well, which is aligned to the exam. There is interactive labs for hands-on experience, but note that this is more for getting you experience with OpenTelemetry because the exam is only MCQ based, right? So there is no labs within the exam. Then everything that you learn with the Prometheus certified associate, that would help here as well because certain things do overlap, especially on the metric side. But then you would learn about the OpenTelemetry's tracing and logging and other concepts like baggage. After this is a direct path to your golden Kubestronaut certification journey. Next slide, Sanjeev. I think that's all about the OpenTelemetry course on what we had to cover.
Yep. And so I just wanted to give you guys a heads up. So the Linux Foundation, they still have a sale going on. So their Cyber Monday or their Cyber Week sale is being extended to December 12th. So you get potentially up to 60% off. You get 60% off on certain bundles, 50% on others. And if you're taking an individual certification, they have a 50% off code. So definitely make sure to take advantage of that because that's going to be expiring tomorrow. All right, so now we can just move on to Q&A. Do you guys have any questions? And if you do, just shoot them into the chat and we'll go through and answer them one by one.
There are some questions there already. Maybe I should read the Prometheus one for you, Sanjeev.
Oh, yeah.
So I think this question is from Anjaneya Lu. Could you please tell me by using PromQL, how can we write queries?
Well, I mean, it's gonna be a little hard to do on just this Q&A, but they kind of follow the syntax that we had gone over. And if we actually go back to here, let's see, where is this? Right, so this is kind of the foundation of the query, right? So you just mentioned the metric name. That's going to give you the most recent metric. And then you can drill down further by using these labels. So when you do the labels, then it'll give you specific time series. In this case, it's going to give you the total HTTP request that had a method equals to get. If you have other properties or other labels on this specific metric, like what was the status code, you could just do a comma and then do, status code equals 400. So that's kind of the principle of the queries in PromQL. They're going to follow that same format. You've got a couple of other functions. So you can do like a rate where you would take this and wrap it in a rate function. It's going to show you the rate at which it's changing, which is interesting for things like counters and other metrics that are, that can only increase and go up. If you want to get a range selected, this is going to show you the values for all of the various intervals over the past 5 minutes. So if you want to build out a nice little chart that kind of shows you what it looks like the past 5 minutes, that's what that range selector would look like. And then obviously we've got a whole bunch of other functions and tools that we can kind of do to manipulate all and get all the data that you're ultimately interested in. So if you wanted to get the sum of a metric over a time period, or get the average, maybe you wanted to get the average rate at which you see requests over a specific time period, you can use one of the aggregation operators. But it's all going to start from here, and then you can kind of mix and match and add in functions wherever you see fit.
Yeah, getting the metric name and then adding those dimensions, getting the range, and then do your aggregation. As simple, and it's a simple query language to learn.
Yep. And for Kafka Talmud, congratulations on passing the PCA. Hopefully you found the KodeKloud PCA course helpful in getting you prepared for that.
That's amazing. Congratulations, Kafka.
The question about the previous sessions, yeah, they should all be on the KodeKloud channel. They're all recorded and saved there, so you can take a look at those. All right. Any other questions?
I think there's a question during the exam, is it one answer per question, or it could be multiple answers?
Oh, for that one, I believe it's one question, but I'd have to double check. I don't remember off the top of my head, actually. I've kind of forgotten.
I mean, I think most of them are one answer until it says select multiple, but most of them I remember as well. It's just one, you select one. And then if there is multiple, you would find it. But if I remember as well, I think there were hardly very few.
All right. Any other questions? Now's the time to get them in before we wrap up the call.
Well, all the best, Brandon, for your first Kubernetes certification that you're about to write in Jan.
I was going to knock both of them out.
Oh, very good. Can't wait.
I'm guessing it's going to be the CKA and the CKAD. Which one are you planning to take first? Just out of curiosity. I personally would start with the CKAD. I mean, this is like very preferential. Like some people say one or the other. I found the CKAD to be a little bit easier. That was just me personally. CKA kind of goes a little bit more into the architecture. So you start off with the CKAD, past that, and then you can just learn some of the more internals of Kubernetes and some of the architecture related things and the administrative side of things. Take a little bit longer to understand, and then you can knock out the CKA. That's what I would say. Other people have said the opposite, so it really just comes down to personal preference. But I find the CKAD to be a little bit easier.
And I think I'll just add, once you understand the Prometheus concepts really well, getting OpenTelemetry would be actually complete the observability journey. And I think people would now know what a trace is, would know what a span is, and then complete the whole story of observability. Because Prometheus plays a critical role, and then OpenTelemetry is going to play an overarching role for not just metrics, but for everything else. So I think from those aspects, continue your journey. Once you do your PCA, go to the next one, do your OpenTelemetry certification as well.
Yeah, and then Brandon, for after the two Kubernetes certifications, you can kind of branch out to anything really, because you kind of have the foundation. You definitely want to have those two first before you kind of move on. But once you go there, it's just a matter of like, what are you most interested in? If you want to move into things like Cilium or Backstage or any of the platform related things, you can kind of do that. But you just want to make sure you've got the Kubernetes side of things down. And from there, it's just a matter of interest. So the difference between rate and iRate is kind of how you calculate it inside the little window. So I believe rate is the first and last data point, and irate compares the first 2 data points. So it's just kind of how your metrics or how your system is ultimately functioning. So if you see a lot of variability between the first and the last, it may be better to go with irate, which compares the first and the second data points in that window. So it's more of understanding how those metrics are being generated, how your system's functioning to determine which one is the better one of the two. And that's going to, usually involve you having to kind of look at the data and see what exactly is happening. Because if there's a big gap inside one little window section, right? If you're doing like a 15-second interval, then you want to go with irate, which will take the first 2 data points. So you get a true kind of slope when measuring the differences between the 2 data points.
And I can add something about dashboards. Dashboards is always about how you want to visualize your data first and then work backwards on how you get the data through the query. So always want to see how would you want to see this data in a dashboard, whether something going up or down is a spike. Is that how you want to conclude it? If that is the visualization that you want to see with the dashboard, use there and then work backwards on how do you create such data in the dashboard. So that's the way in which you typically would want to think about dashboards.
All right, guys. So I think we've answered all of your, or at least most of your questions. So I think we're going to wrap up this session. Hopefully you guys found this session helpful, and definitely make sure to stay tuned for our next session, which will be the final session for this Golden Kubestronaut cohort. So thank you for joining, and I'll see you guys in the next one.
Thanks, everybody. See ya.